Chapter 2, Kuby Immunology, 7th edition. Again, in these early chapters, it's important that you learn the terms, learn the vocabulary. Spend quite a bit of time going over it and making sure you know the terms, because it builds throughout the semester and you're learning a new language. So you really need to take some time to look at what are some of the primary lymphoid organs. Bone marrow, which you normally don't think of as an organ, is one of the primary lymphoid organs. That's where all the blood cells are born. Everything is created in the bone marrow and then moves out from that area. Some of the secondary lymphoid organs include the lymph nodes, the spleen, which is the largest lymphoid organ in your body. Then, of course, you have the thymus and other tissues. Now, what's the difference between a embryonic stem cell and a adult stem cell? What are hematopoietic stem cells? These are terms that you need to read through and figure out. A embryonic stem cell has the ability to become anything, but there are other cells in the body, adult stem cells, that have already established that they're going to become blood. They can reproduce and become any kind of blood, so they can reproduce at the earlier stage and send out their offspring, their divided cells, to become different types of blood cells. But they can't back up and become a liver cell or anything else. So you need to spend a little time looking at that. Now on page 28, there's a graph, figure 2.1, hematopoiesis. And it's going to have a gray section in the middle. That's the bone marrow. That's where everything is happening. Hematopoietic stem cells are self-renewing, so they reproduce themselves. And they can become either the myeloid origin cells. These are those cells that don't require any kind of extra training to become what they want to be. They don't have to go to the thymus gland. So you can get, under the myeloid progenitor cells, you can get all of your granulocytes, the basophils, eosinophils, neutrophils. Your red blood cells, your RBCs, are called erythrocytes. And you can also get one class or family of dendritic cells. Then, if you look on the right side of that figure, you've got your peripheral tissues, where these are lymphoid origin cells. These are those that require some extra training. Natural killer cells count the number of MHCs on the surface of a cell. The T helper cells are going to go to the thymus or some thymic organ for education on what to recognize between self and non-self. And then, of course, your B cells, which are going to mature in your bone marrow, hence the B, are going to produce multiple different kinds of receptors that will recognize different antigens. So you're having to create a B cell that will recognize an antigen it hasn't come into contact with yet. And you may only have one of those. So each B cell will carry its very own set of receptors that are unique to it. The dendritic cells that are produced on the peripheral side, it's hard to even differentiate those dendritic cells from those that come from the myeloid origin. But we'll discuss that in a much later chapter. So, looking at the blood cells, there are things like the turnaround. You have a lot of reproduction of blood cells. So that's why certain types of antibiotics can cause anemia. If you cause some drug to go in and affect the hematopoietic stem cells, or even the myeloid or lymphoid progenitor cells that are produced, then you can dramatically affect the total blood cell count later on. The problem with studying immunology at the beginning was you can't just look at a lot of these blood cells and differentiate them. It wasn't until after the 1970s that we were able to fully isolate the hematopoietic stem cells or any of the stem cells inside the bone marrow. We kind of predicted that they existed, but being able to describe and isolate them was difficult. So the majority of the research in the early 1970s in immunology was looking at ways of isolating stem cells. It was kind of a hot topic back then. So they did things like trying to pan for stem cells. This is where they would label antibodies on the bottom of a plate that were raised against known types of blood. So you've got your eosinophils, your basophils, your leukocytes, your erythrocytes. So you put those antibodies on the bottom of a plate, and then you take bone marrow that's in a saline suspension, put it over that. The ones that can stick to the known antibodies will stick, and that leaves you with your progenitor cells and your pluripotent stem cells that don't stick. So you simply run those through 2 or 3 plates, and you have purified the number of cells that are progenitor or stem cells. So you can actually concentrate them a little bit more. And that led from figure 1 into figure 2, where you have current approaches for enrichment of pluripotent stem cells. Somebody said, well, how do you know that you've got the right cells? And the best way to know is if you can have them reproduce and make more cells. So they would take mice and lethally irradiate them so that there's over 950 rads. I think 1,000 is the most common amount of radiation that they use. And they can inject them with raw bone marrow, and it sets up a brand new immune system. That's kind of like what they do as a treatment for some leukemia. Well, that's if it's got all of the different cells in there. You have to use quite a bit of the raw bone marrow solution. Then you can also take a concentrated version of those, and you put a much smaller amount into this partially enriched cells into an irradiated mouse, and the mouse is restored. It lives. Then if you can really thin it out and isolate the stem cells and inject the fully enriched stem cells directly into the mouse, it only takes a few of them. So that applies directly to human medicine in that if we isolate pure cultures of these stem cells, or if we can generate pure cultures of these stem cells, we can have people with leukemia irradiate them and inject them with very small amounts of these stem cells and have them grow a brand new immune system. It can save lots of lives. I'm going to stop there and do another section on a separate little audio clip.